and we're going to use counting in probability. So we're going to use permutations and combinations like we've been doing recently, and we're going to use it with probability. So the best way to do is just get straight into the lesson. So the question is, in a deck of playing cards, so 52 cards, so what we're talking about is that we're talking about the hearts, clubs, diamonds, spades, sort of card games. And so we need to find the probability of finding 3 diamonds and 1 club in any order. Now straight away, any order should ring out to you, oh, that's a combination, because when order matters, that's a permutation. So we've got to go there already, okay? So let's find the probability of 3 diamonds and 1 club, okay? Now the first thing we need to do is find the denominator. Now the example that I use is like when you roll a 4 with a 6-sided die, the probability of getting a 4 is 1 out of 6. Now 6 is the total outcomes that could occur. So the denominator will always have the total outcomes of what could occur. So that's probably the easiest thing to do already. So if we've got 52 cards, how many are we choosing? We're choosing 4. So that will be our denominator in any order. And in actual fact, if we do it, 52 choose 4, it will be a really big number. So that's going to be over 270,725, okay? Now the numerator, just like in this example of rolling the die, is what we want to occur. So in this case, it was the die one was we wanted a 4. In this case, we want 3 diamonds and 1 club. Okay, so we have to use combinations again. So how many diamonds are there in a deck of cards? There's 13, isn't there? There's 13 in each suit. So from 13, how many are we choosing for this such thing? 3, yeah. And we also want 1 club. Now, and is a very important word because that tells us what to do, plus or times. And tells us multiplication. And then we're going to do the same thing with clubs. So we've got 13, and we're going to choose 1 because we only want 1 club out of 13. Now, both of those have numbers, so we'll go 13, choose 3, so that's 286. And we're going to multiply by 13, choose 1, and that's just 13. All right, let's pop that in our calculator. So I'm going to do that right now. 286 times 13. 286 times 13 all over 270,725. Okay, so the probability of all this happening is quite a unique sort of fraction, and here it is. Okay, so the probability of this happening. All right, the next question is that find the probability of 3 diamonds and 1 club in that order. So immediately we're thinking of permutations, all right, because order matters, all right. So we've got a club as well, all right. Now our denominator will not be a combination, it will be a permutation. We've got 52 cards and we're going to pick 4. All right, so difference because the order matters. And at the top, we're going to think like a permutation. It will be a permutation, but most of our working out has been without using the permutation sort of notation. So if we pick 13 dimes, if we've got 13 dimes to start off with, so the first option will be 13. And then once we picked one, we've got 12 diamonds left, and when we picked another one, we've got 11. And means times in this case, and we also want a club. Now, how many clubs are there? 13. All right. So we put that in our calculator, and we should get an answer. And that's going to be all over 52 pick 4. So it'll be 143 over 41650. All right. So that's our answer for that one. Okay, we're going to look at a couple more examples. Well, just this example. The first 7 positive integers are in a hat. So the first 7 positive integers are just 1, 2, 3, 4, 5, 6, 7. All right. 3 numbers are drawn at random. Find the probability that numbers are 2, 3, and 7. So 2, 3, 7. It will equal, at the bottom, we've got, how many numbers are drawn? 3 out of how many? 7. So we've got 7, choose 3 as our denominator. And then at the top, we need to pick a 2. How many 2s are there? There's only 1. So we're going to go 1 and we're going to choose it. And we need to get 3. And there's only 1 3. So 1, choose 1. And we've got a 7 and we've got to choose it. And there's only 1 7 because there's only 7 numbers in the hat. All right. There's only 7 numbers in the hat. So let's do it. So it's going to be 1, choose 1. So in actual fact, the numerator, which is the top, will only be 1. And so we'll have to just go 7, choose 3 as our denominator. So the chances of that happening is 1 out of 35. All right, second number. Number 4 is one of the numbers drawn. Okay, so let's do the same thing. We know that 7 choose 3 is 35, so I'm just going to use that. So 4 and others, because there's going to be 2 others that will get drawn. So our denominator will be 35, and our numerator is that we have to pick that 4. So out of that 1 4, we have to pick it. And then there's no other restrictions. So how many numbers are left? There's 6 because we've picked 1 out. And we're going to choose 2 because that makes 3, and 3 numbers are drawn at random. So what's 6 choose 2? Because that's just going to be what? So it's going to be 15 over 35. Okay, so we need to, number 1 is one of the ones drawn. And yeah, so yeah. All right, so 15 over 35 will simplify down though. So 15 will simplify down to 3 over 7. All right. Now the C, we can think about it 2 ways. If number 4 is not drawn, that's the opposite of this, okay? So we should expect the answer to be the complement of it. So 4 out of 7. So the opposite of what this is, or this one, but that one, the second one is reduced down. But let's just think it through again. So let's go probability 4 not chosen. So the probability of 4 not chosen is that we have to take 4 out of there. So we have to take it 4 out of there. So how many numbers do we have? 6. So we're going to 6 and we're going to choose 3 and it's going to be over 35. So let's do that. 6 choose 3 equals 20. So it's going to be 20 over 35, which indeed does reduce to 4 over 7. And in actual fact, that calculation we didn't need to do for the reasons I just outlined. So just be aware of that as well. Okay. Now the last one is interesting. It goes number 2 is not drawn. So we've got to take number 2 out, but remember number 4 is back in it. Oh no, number 2 is drawn. Sorry. So this will be 1 choose 1 because we have to pick the number 2, and then number 6 is not drawn. So what we have is after drawing the number 2, we have 6 numbers left, but the question says number 6 is not drawn. So how many numbers do we have now? 5. And we need to choose how many more to get 3? 2. All right? And so let's just work that out. 5 choose. So it's going to be 10 over 35. So the answer will be 2 over 7. All right, that's the end of the lesson. Just think the question through. Look for and look for or. Or means plus. And then just think of the total pool that we can choose from and then work things out. Anyway, hope that helps. Peace out.